Yes, members, you are most welcome once again. I hope yesterday was fine for you, and sincerely, you are doing a very great job to support and to always move with me. I want to appreciate you in a special way that as long as we are together, I want to tell you that you will always get whatever you want, and whatever you order for is what you will get. Are we together? Now, like this number that you are seeing right there, someone actually requested, one of you requested that I should go through and explain it further for people, because for those who know it, it appeared one time somewhere, and someone expects me to go through it and see what we can do, so that we are able to know how things can move. I told you that this is the room for application. We shall always learn how to apply knowledge. I told you, and I'll always remind you, the trend is application everywhere. And why our children are failing mathematics is because they don't want to apply. Reading questions to understand and to interpret them in a normal situation, real life situation, is a challenge. We are going to look at all these questions. There's a very interesting question I'm bringing after this. In the next lesson, I'm going to bring a very interesting lesson that will pop in anytime. And the public also needed about distributive property. So I have prepared distributive, associative, and commutative. All we shall have that, and everything will be moving on well. So members, thank you very much. We can move on and we are good to go. Now, in the figure below, BCD, in the figure below, BCD, yes, we are moving as we are demonstrating it here. BCD, the figure below, BCD is a straight line. You can see from here to here is a straight line. Line BX, line BX bisects, line BX bisects. I hope that one should be very clear in our ears. To bisect means to divide. Not only to divide, but into two equal. That word equal. To bisect means to divide into two equal. That is a key word. Some of us at times mistake, we think to bisect simply means to divide. No. Not only dividing, but into two equal parts. So BX bisects angle. BX bisects angle ABC. ABC. The middle one. That's why they are made this angle here. The movement, you can see ABC. The angle is formed around here. This is the angle formed around here. Now line BX has bisected, in simple English, has divided angle angle ABC into two equal parts. Bisects angle ABC into two equal parts, divide this into two equal parts. Line AB is parallel. Line AB is parallel to line XC. Parallel. These are lines that have equal distance between them. Equal distance. And remember, parallel lines do not meet. They do not meet. They have equal distance. If they are drawn, for example, they look like this. The distance from here to here is equal to the one from here to here. So when you continue drawing without adjusting distance, even if you draw it for 1 million years, they will never meet. They will never meet. That's why they are saying that line CX and line AB are parallel. Property of angles on parallel lines. Members, I know you have gone through But when time comes, if there's need, we can still revisit them, because I made a video one time about this some time ago, but I hope I can still refresh it and make another one. This line BA or AB is parallel to line XC. Angle BCE, where is angle BCE? BCE, this angle is 50 degrees. Don't forget the symbol is 50 degrees. And angle BAC, is that angle which is 70 degrees. Members, it's very important to understand a certain figure. This angle, you need to be able to understand all the, because it's involving a lot of properties, a lot of them, a lot of properties. It's for you to interpret them very well, following which one is dropping where. Because that means you mess up with one, everything becomes a mess. Interpretation now. Angle BCE is 50 degrees, which is here. Angle BAC. This middle letter is where the angle is. That is a simple way of understanding this. As you can see, BAC, the angle is at A. Then BCE, the angle is at 50. BC, C is in the middle. That's a simple way. But an angle, you can see that folder here from BCA. This folder here is what we are calling that. Now, having understood how our figure is standing, we now want to calculate the size of angle CEX. Are we together? CEX. Which angle is that? CEX. CEX. You can see CEX. This one here. CEX. Let us not mistake this. CEB is the other one. CEB. CEX. That thing confuses our learners. You as a teacher, you can understand, but our learners, they needed that interpretation. They need it to be simplified to them so that they move on. Just emphasize to them CEX, as you can see the angle X weight is moving, shows where the angle is to this side. Then CEB, B is there, the angle is there. The last letter is moving that side, so the angle is here. Just very simple. So that's the angle they need. But when we are calculating angles of this kind, we always use a lot of assumptions. Why? We pretend sometimes that we are not seeing other lines. So we assume this time that we are not seeing this one. Allow me to do it from here so that you can see those who are following. Now, when we assume that line is not there, we are assuming what happens there. We assume that the line is not there and this part is no longer seen. We have covered here. You will realize that you have something which looks like this. This is A, this is B, this is C. Now, here is 70 degrees, here is 50 degrees. Now, what about here? Remember angle property in a triangle. Very simple from primary 4 class. Angle property is here. Interior angles of a triangle add up to 180 degrees. So if it is 180 degrees, you will say 180 degrees minus 70 degrees plus 50 degrees. So 180 degrees minus 120 degrees, which equals to 60 degrees. So this one is 60 degrees. The whole of this angle here is 60 degrees. Now, if the whole of that angle is 60 degrees, remember that when we now take back our line, this one is 60. We said that line BX bisects, divides angle ABC. Remember, angle ABC is 60 degrees. Now, if this BX is dividing into 2, 60 divided by 2, what do you get? Here, you will have 30 degrees. Here, you have 30 degrees. Very simple. After something very simple, we only move on and see everything coming out the way it is supposed to be. Here 30, here is 30. We are moving on, by the way, to the root of getting angle CEX. CEX. Now, angle CEX becomes very simple. Actually, too simple when you have something like this. When you have something like this, you pick this smaller one. That one there. This is B. This is C. Remember now this one, from here, we are picking this 30 only. This is 30 degrees. This is 50 degrees. Now, if this is 30, remember angle property in a triangle. This is 30 plus 50, which is 80. So 180 minus 80 is 100 degrees. So this angle here is what is here. This is 100 degrees. Just moving very simply without any problem. Now, if this 100 degrees, we now go back to this line. You assume that others are not there. You pick this line, which moves like this. You can see in primary 4, they have always brought for you this kind of angles. They say calculate value of angle P. Remember, this angle P now is where this angle CEX is. Very interesting and very simple. We are moving slowly. We began by removing this line. We assume we're not seeing it. We had this. We got this one as 60, and we say line BX bisects angle B ABC into 2, or divide this into 2 equal parts. That is 30, 30. Now we have picked these two here. This one, interior angles of a triangle add up to 180 degrees. This is 30 plus 50, which is 80. 180 minus 8 is 100. Now this is the part 1. Now the angle we have got here is CEB, which is 100 degrees. Now we want this angle. We move slowly. We don't make things very complicated for these learners. So these are straight line angles, which is P plus 100 degrees equals to 180 degrees. So when you collect like terms and you subtract, you will find that you have 80 degrees. You will have 80 degrees, of course, and that's what will be there. Now this angle P is what we meant to be this part here, which is 80 degrees. 80 degrees. That means CEX equals to 80 degrees. Just moving slowly without even involving it first, you'll find yourself calculating. But remember, that's not the only way of how to get the value of CX. There are very many ways. But me, I'm looking at a cheap way. Let us not make things complicated for learners. Let us make things very simple from what they have understood. Now you see the way I began from a triangle, which is taught right from primary 4. How to get these sides angles missing. That one I began from there. Primary 5, they are so much used to this one. So when I began from that point, in fact, I've not introduced any other thing. From there, I moved to another triangle also after explaining for them very well. From this point, I went and used still angles on a straight line, which is very common in those classes. In lower, P4, P5, they are common there. But you find that this question, they just combine things that comes in PLE. And the child complains that the number was very hard. Yet, there's only a combination of properties of these angles. That's how simple it is. And I expected you people to have this, and very simple like that. Move on well. Now, that one being part A, let us look at the part B of that same question. That is DCX. DCX, that is this angle here. How do we get this angle? That one is very simple also, as we can see. Since this angle is now 80 degrees, and we have this angle here that we have to calculate. We can do it in many ways. We can get this angle. You see, we can get this angle. After getting this angle, we can get this angle. Then we add everything here, from here to there, to give us 100 what? 80 degrees. If you look at this angle, since it is 30, this one is 100 degrees. We can now come up and we see how best we can calculate. I want to look for that cheap way that we can use to calculate that value that we want. This angle 70 is equivalent or is equal to this angle of 70. This one. Remember, these lines are parallel. Those lines are parallel. So this angle plus the other one is equals 180. I mean they are the same. Now the whole of this one here from here to here is 180 degrees. If this one is k, so we shall have k plus 50 degrees plus 70 degrees equals to 180 degrees. So this is k plus 120 degrees equals 180 degrees. So when you subtract, our k will be 60 degrees, and that k, remember, is what we said, it is this x, which is 60 degrees. Angles are very simple to handle. Someone else will find this angle, which is 30. Even if you had found another 30, this one will still give you 70. You find things moving on well and everything will be fine. So I'm going to give you one of the numbers you try, but that is how we would have gone through this question. It's all about interpretation and understanding. Otherwise, thank you very much for attending, and thank you for giving me your time. May the Almighty God bless you abundantly. Greetings to you all.